Good morning. Let's get going on lesson 4.2. So in the Google Classroom, make sure you open up session 4.2 or from Power School Learning, lesson 4.2. Take your attendance, and I'd recommend being online with me live. If you're watching this, you're probably not. That's okay. You're doing this right there. And so that takes us to number 3. Make sure you open up your link number 3 to be able to submit answers as we go along. So that's where we are right now, is link number 3, and I'll have that open. And good bet, we'll be using calculators today. So right under link 3, this little bullet point, open up your Desmos graphs. We'll do that as we go through today as well. All right, so let me open this up and we'll get started on the bell ringer here. There we go. So we're on number 1 here. It says solve triangle ABC, round side lengths to the nearest tenth and angle measures to the nearest degree. So the key I gave you last on lesson 4.1 is that whenever we look at a triangle, we're going to look at it as the x and y axis, where your angles are on the x-axis. So the thing I first taught you was that, hey, you can always just turn your triangle to where the 2 angles are on the x-axis, and then you can solve from there. Or the other option is you could always just solve for this angle and call this one theta and ignore the 59 the rest of the way. Since I'm going to have to solve the whole triangle, I'm just going to turn it this way and show you this technique. So what I'm going to do here, and this is going to seem crazy at first from the way we taught, I was just showing you an extra way of doing this, is I'm going to make this kind of look like the x-axis, or the y-axis, I'm sorry, and this become my x-axis. But right now my angles are on the y, which would be problematic unless, here's the big key, I find the angle right there. So I'm going to call this one theta, and I'll find this angle first. And the way we do so is that going off the geometric rule that every triangle has 180 degrees. Let me try to turn this a little bit more to get it right. There you go. And so this angle right there, it's going to equal 180 minus this 59 minus this 90. And I'm just going to open up over here on my Desmos. I'm going to go to the spring semester, and I'm going to open up the right triangle trigonometry link. And so here are my 6 trig functions, but right now I just want to do this math. So I'm going to say 180 minus 59 minus the 90, that is 31 degrees. So that's the theta I'm going to be using the rest of the way to solve. I'm going to say this is 31 degrees. Now, the only thing left, since I found all 3 angles, part of solving the triangle is finding all 3 angles and all 3 side lengths. We're going to find the C and the A. Now, C is in the place of y. It's on the y-axis. So I'm going to solve that one using a y, and I'll solve A, since A is on the x-axis, as being an x. The 23 represents my hypotenuse, my h. Okay, so let's just go in alphabetical order. I'll find the A first. By the way, we would label that angle C. So I'll put it over here. That capital C, which means angle C, is 31 degrees. So now let's solve for the little a here. The little a is on the x-axis. So I'm going to solve for A. If I want to solve for A, I need to use a known value with it, which is the h. So I'm solving for x, and I have h. You always want your unknown on top, or in the numerator, over the known, the denominator. So numerator, denominator, it's going to be x over h. So when I look through here, there's only 1 out of 6 trig functions that has x on top of h. And very specifically, you want the one that you're searching for on the top in the numerator. So I'm going to choose cosine, because that one very specifically has the x on top of the h. I don't want h on top of x, I want x on top of h. So I'm going to use cosine. So the cosine over here, we'll do it right above. This is to find A. So this was to find C. So to find our A, we will say that cosine of the x-axis angle, 31 degrees, equals the unknown x value over our known h value, which is 23. All I did is I plugged into this formula right there. Cosine of the x-axis angle, 31 degrees, equals unknown x over the known h of 23. So there it is. And to find x, we need to get rid of the division. The opposite of division is multiplication. So I would multiply both sides by 23. So let's go see what this value is. 23 cosine of 31 degrees. It's going to equal 19.7. I'm going to round to one decimal place. So we're going to say this value right here is 19.7. And I did a squiggly equal sign, just means I'm rounding there. So that's A. A is approximately 19.7. And now, if I want to find my y-axis, my c value, I have to write that over here. The c value is a y over the unknown, or the known, excuse me, h. So the unknown is over here, y. That's going to go in the top, the numerator. This is the known, which means it's going to be the denominator. So y over h. I'm looking for y over h. Only one of these six has y on top of h. Y in the numerator, h in the denominator. Which one is it? It's sine. Sine is our value we're going to be using here. So I'm going to say that sine of, again, the x-axis angle, 31 degrees, equals the unknown y over our known h of 23. Again, I would have to multiply by 23, just like I did over here. I'm going to do that again. I've run out of space, so I'm just going to type it in. I'm going to trust that you get the algebra. I'm trying to get rid of division, so I multiply. So what I'm going to type in is 23 sine of 31 degrees. And I'm getting, when I round to one decimal place, 11.8. That rounds down. The 4 rounds down, so it's 11.8 will be our c value. Now you can go and enter your answers into the correct value here. All right, number 2. What I'm going to do now is I'm going to create some space. And I'll have to come back to that in a second. Let me do it this way. Let me clone that. Okay, so let's do number 2. Number 2 says this. If cosine is 3/5, find the exact value of the 5 remaining trig functions of theta. So here's what we have. On an axis here, we have, well, before I say on an axis, because we don't know necessarily what cosine represents. Cosine represents x over h. So what that means is on an axis, if I were to graph this on an x and y axis, we do not know the y value. That's unknown. But we do know the x value. The x is 3 here. And we also know the hypotenuse is 5. So either way, I know I'm going to go 3 units to the right. So we're going to have a triangle that goes 3 units to the right. And we know the hypotenuse. Now, though this is going to change once we get to lesson 4.3, today's 4.2, if they don't tell you positive or negatives, you're just going to assume the unknown is a positive value. So if they don't tell you what you're missing, whether it's positive or negative, we're just going to assume that the y is going to be a positive value. So here's what I have right now. X is 3, the h is 5. Here's my right angle, and this would be my theta. We don't know why, but we're just going to assume it to be the positive value since they didn't say anything else, any extra pieces of information. So the first thing I'll do to solve is I'm going to show you we can use Pythagorean Theorem. So if you remember the Pythagorean Theorem, we normally say a squared plus b squared equals c squared. Well, I'm going to actually use it as x squared plus y squared equals h squared because c represented the hypotenuse. That's now h. So I'm going to use this formula here. We know 3 is x. We do not know y. H, though, we do know is 5. So if I go to solve this, 3 times 3 is what number?
9.
9. I don't know, y squared. And 5 times 5 is?
25.
25. We subtract our 9 from both sides. We find out that y squared equals 16. Now, how do you get rid of a square?
Square root.
Square root. Okay, in math, anytime you add a square root, technically speaking, we would say plus or minus. And so we'd find the values either plus or minus 4. But what we'll do with trigonometry, if there's no indication whether it's positive or negative, meaning no extra information, we'll just assume it's a positive value. That's just how they kind of operate with trigonometry. They just assume it's going to be the positive. And so we'll say that y is the positive of 4 rather than the negative of 4. And so now we can write our trig function. So it says write the 5 remaining. I'll just write out all 6, and I'll do it right over here. I'll just go in order. So the first is sine. Sine is y over h. So we'd say sine is y over h, 4/5. 4/5. That's y over h. Cosine, I know it says it right there, but if you use this, you'd say cosine is x over h. Here's my x, there's my h, it's 3/5. And I forgot to write on there. 3 is my x. Okay, tangent is y over x. So sine is y, cosine's x, tangent is y over x. Tangent would equal y over x, 3 over 4. No, I'm sorry, I got dyslexic, 4 over 3. And now we do the reciprocals. Sine's reciprocal is cosecant. So C is C theta. You flip the fraction here, you take the reciprocal. It's 5 over 4. It's h over y, 5 over 4. Cosine's reciprocal is secant. Again, you could get that right there, secant. And it's its reciprocal, so it would be 5/3 h over x. And tangent's reciprocal is cotangent. And it is x over y, 3 over 4. So that's how you get the answer to number 2. Again, if you're following along, I'd recommend you go over and type in the answer here. You're looking for the one that matches. They don't list the cosine, but you're going to look for the one that matches the other functions. And now let's go on to number 3. Move that out of the way, that out of the way. Give us some space to work with here. Okay, number 3. It says find the value of x, round to the nearest tenth. Okay, first question for the class. Am I able to go straight to my trig functions? Let me pull those up. With it turned this way. Could I enter values straight into my trig functions right now with this shape turned in this direction?
No.
No, very good. Why not? What's wrong, Joshua?
I think that the x is it's not supposed to be there because it's supposed to be on the y instead.
Okay, so you might be talking about the letter X. It should say Y. Yeah, if that's what you're saying, I would agree with that. And also, there's a rule with the way you turn a triangle is that you want both angles always to be located on the x-axis. So right now, I couldn't just plug in these values. What I could do, though, is turn the shape this direction. Uh-oh. Let me move this to front here. Order, bring to front. I could move the triangle this direction. Now, if I treat it this way, now my angles are on the x-axis and it's labeled properly. So this is probably the good way of solving. But what I will do is I will show you in a second how we could solve it, turn this way, and still get the same answer. I'll walk through that secondly. So I'm going to do this first on the right. I'm going to solve this one, and then I'll come back to that one. I still don't think I have that quite straight. Let me get this a little more straight. Okay, so let's add our x-axis and y-axis. So here's our y-axis, and here's our x-axis. Step 1, I want to make sure I have the angles on the x-axis. That's going to be my step 1, angles on the x-axis. Angles on x-axis. I should have written that on the first few problems. And so that's step one. Now, step two, to solve. I want to make sure I'm finding the x, which that is the x, that's my x-axis, this is my y, over my hypotenuse, which is equal to 18. So x over h. I'm going to give you all a second to look at these over here. I'll give you 5 seconds. Looking for x on top of h. 5, 4, 3, 2, and 1. Which trig function has x divided by h?
The second.
Yeah, good. All three of y'all, great. The answer is cosine. Cosine has x on top of h. So step two would just be to solve the problem here. And so I would use cosine of your x-axis angle, which means 61 degrees, equals x over the unknown, or the known 18. And again, the one step you'd solve this is to get x by itself, you need to multiply out that 18, because right now it's dividing. The opposite of multiplication, excuse me, the opposite of division is multiplication. So if we type that in the calculator, we should get our solution here. 18 cosine of 61 degrees, answer is 8.7. So when I round, I'll say 8. It says round to the nearest tenth, so I'm going to say that x is 8.7. And that would be my solution there. Okay, so what if you wanted to use the triangle this way? So you can. Here's the deal. We kind of talked about this at the end of lesson 4.1, is that you can use the triangle even if your angles are not on the x-axis. If you, first step, so I'm going to draw this in. Then to complete the first step, you need to find the x-axis angle. So I'll treat this as theta. And as long as I find that, then I can use the triangle in this regard. So I've changed it to where this is now my y, this is my x, which means I'm not going to leave that as x because that's confusing. I'll change that to a y. And so I would need to find the angle before I proceed further. So this is a 90. This is 61 degrees. If I subtract from 180, I can get theta here. So let's come over and try it. 180 minus the 90 minus the 61, I get 29 degrees. And so you could solve the triangle with it turned this way if you use 29 as your angle. So now I'm looking for a y over an h. So I'm looking for a y over an h. And so it's no longer cosine. Notice it's now sine. So sine of my x-axis angle, 29 degrees, would equal y over h of 18. Again, you multiply that by 18, and we'll see that this gives us the exact same answer. We'll find out that cosine of 61 is the same thing as sine of 29. Let's type this in. 18 sine of 29 degrees. Notice these two answers are exactly the same. So hopefully that's an extra little trick in your tool belt to know, oh, it doesn't matter which way I actually turn my triangle, as long as I'm able to get an x-axis angle, as long as I do that, I can use the triangle standing up tall or having it laying on its side, if you will, and you'll still be able to solve. So that's a review of lesson 4.1. We're now going to go into 4.2, which has to deal with those degrees and radians, with those pesky little modes here, degrees and radians. That's what we're going to do now.